Thank you all. I'm sure most of you are veterans of the forum and are familiar with lightning round talks, but just a quick refresher. And while I give that refresher, if we could just have the first 5 or 6 or so of you go ahead and come up here on stage right, and we'll go ahead and do the presentations in this order. And then as it goes down, just keep coming up in the order stated. Anyway, lightning round talks are an opportunity for the next generation to stand up here and in a minute and a half tell you what they are doing. What is the status of their research, who they are, where they're working, who they're working with, maybe an interesting tidbit or note about it, and a chance for them to plug their poster or talk that they're going to be giving later on. And so they do not have any slides, and there will not be any questions from the audience at this time, but I highly encourage you all to come up to them at their posters or come to their talks and ask your questions then. They are also likely all looking for opportunities for postdocs, et cetera, and hopefully they'll tell you where they are in their careers as well. So with that, we'll go ahead and get started, and when there's about 15 seconds left, I'll wave my hand, and when there's 0 seconds left, I'll use my big candy cane to yoink you off the stage. Okay.
Good morning, everyone. My name is William Good. I'm a graduate student at the University of Colorado Boulder. I work with Professor Sasha Kempf, who is the principal investigator for the Surface Dust Mass Analyzer, or SUDA, which will be on the Europa Clipper mission launching in 2023. During close flybys of Europa, this instrument will take chemical composition measurements of the ejecta cloud near the moon. And my work involves developing models or developing distributions for the launch sites of these ejecta particles so that we can map chemical composition measurements to their site of origin on the surface, build a compositional map of Europa to understand this world a lot better. So I have a poster near the back of the poster room near the emergency exit. Should be easy to locate. So again, my name is William Good, talking about Europa. Thank you for your time, and I look forward to our discussions.
Hi, everyone. I'm Zach Olivati, and I'm about 1.5 years, 2 years away from getting my PhD at the University of Colorado, where I work with Tobin Munsat and Mihai Hirani. And I study hypervelocity dust impacts into ice surfaces. And I study the chemistry of the impact plume as these micrometeorites impact. And I study it using time-of-flight mass spectroscopy. And there's 2 important avenues of research for this. On the one hand, we can use this to study the long-term chemical evolution of the surfaces of icy bodies in the outer solar system as a result of dust bombardment. And this is also important for a certain class of instruments, the impact ionization time-of-flight mass spec, like SUDA that Bill just talked about, for example. And so this year we kind of have some interesting results for both of these avenues of research. With regard to the impact ionization instruments, we have some hints that, of course, these instruments would be interested in studying complex organic chemistry like amino acids at Europa. And we have some hints that even upon breakup, even if the amino acid shatters when it hits the spacecraft, we actually still might be able to tell you what that amino acid was. We might be able to use fragmentation as a fingerprint. And on the other hand, with respect to surface chemistry, we have some hints in our data that we might actually be increasing the complexity of organic chemistry in the ice as a result of dust bombardment. So in the outer solar system, dust might actually be changing surface chemistry. So I'll be at the poster today till 5:30. That's going to be poster 41. Once again, Zach Olivati. Thanks.
Hi everyone, my name is Nivedita Mahesh, and I'm doing my PhD in astrophysics at Arizona State University. I'm working with Dr. Judd Bowman, and I'm also a part of the NESS collaboration. For my research, I'm studying the prospects of developing a radio array on the far side of the moon. I focus on 3 main aspects of the array. 1, to develop an optimized antenna for the lunar surface. 2, to give you a low power processing architecture that would be useful for any such space-based mission. 3, to carry out sensitivity analysis of this array for our desired science cases. A lunar array is uniquely poised to answer some of mankind's most profound questions. What are our cosmic origins? Is there life elsewhere? But it's important that such a mission is taken in stages, and I'm more than overwhelmed to tell you that this concept proof of study for the array was recognized with the finest award this year And I hope to have some useful discussions at my poster number 43. Thank you.
Hello, my name is Wesley Chambers, and I work at the Center for Lunar and Asteroid Surface Science at the University of Central Florida with Addie Dove and Phil Metzger and Dan Britt. I am interested in the question of what happens if you try to land on the surface of an asteroid. I'm studying plume surface interactions in vacuum microgravity. And so some of the questions I have is, what happens? What are the effects when you try to land on the surface? What do the ejecta look like? What are the potential hazards to a spacecraft? So to answer this question, I'm working on an experiment, drop tower experiment that we take, drop about 10 feet, and it sends a jetting gas into Regulus simulant. So if you'd like to see what this looks like, please stop by my poster number 34, and I'll be there during the poster session. And I'd love to talk with you about what this looks like, what we're learning, and what the potential implications are for planetary exploration. Thank you.
Hello, everyone. My name is Kristen Lusinger, and I'm working with Nancy Chanover at New Mexico State University. I moved from polar icy Alaska to the hot desert New Mexico, and I ended up studying polar ices. So my current project is working on modeling the L-Cross impact debris plume. I'm using a stratified lunar sediment model with layers of surface mixed ice and regolith, dry regolith, and bedrock. And I'm able to match the observations with that model using no other dependent variable. So this is a really great opportunity to look at the pre-impact lunar sediment. So the actual sediment in the crater floor, not the material in the debris plume. So it's a really exciting model that I've been working on, and I would love to talk with you about it. My poster is number 6-9 in the first of the rooms. Again, my name is Kristen Lusinger, and I would love to talk to you about my water ice results.
Hi everyone, my name's Alex Hedgedis, and I'm very happy to be here. Currently finishing up my PhD at University of Michigan, working with Justin Casper. My work involves fleshing out the data processing pipelines and science analysis for various space-based radio interferometer concepts. The work I'm presenting here today is about the prospect of a lunar near-side array that would be observing the Earth's magnetospheric emissions. Specifically, observing the synchrotron emission from the radiation belts could enable proxy measurements of the Earth's electron distribution within 6 Earth radii. This would be of scientific as well as practical concern because it would give us a way to estimate the remaining lifetime on satellites without energetic particle detectors. At our poster number 42, we describe exactly what it would take to detect this signal on the near side, showcasing a pipeline combining LRO-LOLA data with SPICE ephemeris and CASA radio astronomy imaging algorithms to take simulated pictures of Earth's synchrotron emission. It's worth noting that an array capable of these measurements would be able to localize transient auroral events with high precision, providing local small-scale electron data in addition to global distributions. We show that in typical conditions, a 10-kilometer array with around 16,000 antennae could be able to measure this emission multiple times a day. I hope you come over to poster 42 and learn more. Again, I'm Alex Hedgedis. Thank you very much.
Hello, everyone. My name is Ben Melankoff. I'm a graduate student at the University of Colorado Boulder in the Aerospace Engineering Department, where I'll be graduating in just a couple of weeks with my master's degree. I'm the student director for the Low Latency Telerobotics Group, where we work with Dr. Jack Burns, and we focus on setting up hardware and designing various experiments to test aspects of low latency telerobotics applied towards future space exploration missions where humans and robots will be working collaboratively to make scientific discoveries. The details of our most recent experiment will be saved for my colleague Arun Kumar, and he'll share some of the major takeaways from that experiment. But I hope to see all of you at my poster, which is poster number 67. Thank you all for listening.
Hello, everyone. I'm Bhavesh Manivanan. I'm a full-stack developer intern here at the Surrey Central Office. I'm a rising sophomore in computer science at the University of Illinois at Urbana-Champaign. And this summer, I've been working on a publication database for Survey. Basically, this publication database will streamline the process of submitting new publications as well as maintaining the existing publication data. And some of the cool features that my website has is a robust search experience, allows you to search for keywords, and allows you to apply filters to sort out publications based on student-involved, international, and cross-team publications, as well as for team-specific publications as well. And in fact, I could also export the search results into a CSV file so that you could easily access them as well. And after a wonderful experience yesterday with the Survey Executive Council, I've going to be planning on adding a feature that allows you to view author information as well. And if you guys are very interested in my publication database, feel free to stop by my poster number 80. Thank you so much.
Hello, I'm Caden Jepson. I just graduated from UC Davis with my bachelor's, and I'm here today to talk about my research from my advisor, with my advisor, Dr. Stephen Robinson, as part of the HR VIP lab at UC Davis. This is part of the Reveals grant, in which I try to take the electrical signal from soon-to-be novel-based dosimeters and turn that into something meaningful for an astronaut to read the radiation levels while on an EVA. And this has led to me creating, with Janine Moses, a proof of concept helmet. And we'll be showing that off today at the poster at poster number 14. So thank you.
Hello, my name is Christopher Kramer, and I'm going into the third year of my PhD at Brown University, where I work with Jack Mustard and Carly Peters. My previous work has related predominantly to the remote sensing of Mars, and I've done work related to the landing site selection process for the Mars 2020 rover. My recent work has involved infrared spectroscopy of silicate minerals in the lab. I'll be presenting a talk tomorrow at 11 in parallel session 2 about my work on the spectral character of olivine in a region of the infrared that has generally remained unexplored for the 4 to 8 micron spectral range. And I would be eager to talk about anything in that area that might be of interest to you all. Thank you very much.
Hi everyone, my name is Janine Moses. I'm from University of California, Davis. I'm finishing my undergraduate degree next week in mechanical and aerospace engineering. And I also worked with Caden under Dr. Steve Robinson. And we designed a proof of concept for a real-time radiation dosimetry indicator using a T-38 flight helmet and a tandem bicycle. So if that piques your interest, stop by poster number 14 and we'll tell you more about it. Thank you.
Hello everyone, my name is Michael Walker and I'm a computer science PhD student at the University of Colorado Boulder. I work with Jack Burns and Dan Safer, and my work, and I'm also a JPL intern this summer. My work has typically taken the form of combining human-robot interaction with augmented and virtual reality technology. Or in other words, how can we take steps forward from these older traditional interfaces such as 2D monitors and screens to interact with these robots. So for example, in augmented reality, what's the optimal design to display current robot state or telemetry data or sensor readings in a 3D holographic interface that we could place in the center of a room that users could stand around and interact with in 3D. Or in virtual reality, what benefits can we gain by using this technology to stream robot video streams and gain the ability to see with depth and a more immersive experience where we can feel like we're embodying these rovers or robots in distant places? Or how can we improve these interfaces, such as adding head tracking, hand tracking, or even utilizing point clouds? So if any of this is interesting to you, I'll be giving a talk later Thursday. And thanks for having me here. I'm excited to be here. Thanks.
Good morning. My name is Arielle Deutsch, and I'm a PhD student entering my 5th and final year at Brown University, where I work with Jim Head. And I'm also a NASA graduate fellow at Goddard, working with Greg Newman. My dissertation is focused on water ice located at the poles of Mercury and the Moon, and generally I'm interested in processes that deliver and modify ice on airless bodies. And tomorrow morning, over in the other room, I'll be speaking about how the surface temperature of the Moon can influence our measurements of normal albedo. So again, my name is Arielle Deutsch, and I look forward to speaking with everyone this week. Thank you.
Hi, my name is Nicole Torres. I'm a recent PhD graduate from USC, but I'm actually here as part of NASA's Frontier Development Lab, which is basically an 8-week research sprint program that runs in the summer. And the idea is to bring together researchers from space science and from artificial intelligence and machine learning and try to really take these problems head on and see what new techniques we can apply to space science. So I'm here with the Moon for Good team. What we're doing is focusing on trying to use data fusion and machine learning to study the lunar surface and in particular look for resources, so things like iron meteorites that may be on the surface. So we're doing some really cool work. We're being able to do a lot of sort of big data things because we have a lot of compute capability, and we're really excited about what we're doing. So we're actually hosting a session across the hall at noon. So we're going to give a little bit of a talk, and then we want to get some feedback from you guys. So if machine learning and AI is something you guys are interested in, and lunar resources, lunar mapping, things like that, we would love to hear from you. Thank you.
Hi everyone, my name is Valentin Birken. I'm a second-year PhD student at ETH Zurich in Switzerland and the Max Planck Institute for Social Research in Göttingen, Germany. I'm part of the awesome NASA FDL team and would like to re-invite you to our talk in like 10 minutes from now across the hallway. Besides FDL, I'm interested in lunar rockfalls and particularly 2 topics. The first one is detection of rockfalls in satellite imagery using deep learning and machine learning approaches and big data, of course. And then secondly is I'm interested in lunar soil mechanics. So I use rockfalls to study the properties of regions such as the lunar South Pole, for example, or pyroclastic deposits and PSRs. And I have a poster on my research today, poster number 23, and a talk on Thursday at 2:15 p.m. in this room. Happy to see you there. Thank you very much.
My name's Alessandra Springman. I'm a PhD candidate at the University of Arizona, and I have a poster on work I've done with Dante Loretta in support of the OSIRIS-REx mission, and also it's relevant to in situ resource utilization, namely if you're trying to heat up asteroid regolith to get water vapor, for drinking water, for propellant, you have to be aware that you may be releasing things like sulfur or mercury or cadmium or arsenic, which are not just toxic to humans, but also can have adverse effects on purification apparatus. Mercury can cause aluminum metal to become brittle. Sulfur can poison platinum electrodes. So these are things to be aware of if you're considering trying to get water from asteroids. My poster is number 11. It has a water bottle on it. So I hope to see you all there. Thank you so much.
Hello, my name is Noah Hood. I am going into my senior year as an undergraduate at the University of Colorado Boulder. I am working on electrostatic dust lofting under the supervision of Minh Arun and Shu Wang. And on my poster, I talk about how we show that the peak dust lofting rate can support the lunar horizon glow And we also show a velocity distribution of initial velocities and show that it is initial velocities are inversely proportional to the size of dust particles. We also are beginning investigations into the effects of imposed magnetic fields on dust lofting, and we show that this could have an impact on lunar swirls and other phenomena. My poster is number 36, and I hope to see you all there. Thank you.
Hello, my name is Keith Tauscher. I'm a PhD student at the University of Colorado. I work with Jack Burns. I should be getting my PhD in the next year or so. And as part of my work with Jack on the NEST survey team, I work towards developing a data analysis pipeline for the Dark Ages Polarimetry Pathfinder, the DAPPER mission that Jack was talking about. So we have a poster on that, poster number 44. That's on the pipeline, and there's another poster, 45, showing why the lunar orbit is really necessary for DAPPER in the first place and why you can't do this science from anywhere else. So once again, posters 44 and 45, and I'm Keith Tauscher. Thank you.
Hi, my name is Arun Kumar, and I'm a mechanical engineering undergraduate, and I work in Dr. Jack Burns' telerobotics laboratory. So our research group has been developing a telerobotic simulation system, which consists of a rover integrated with a robotic arm and cameras, which allows the operator to perform telerobotic assembly tasks. And we wanted to focus specifically on assembly tasks because as of right now, no telerobotic assembly tasks have been attempted on a foreign planetary body. And with the Artemis program just starting up, there will be plenty of opportunities to perform assembly tasks on the lunar surface. Our team devised an experiment to assess the operator's situational awareness and cognitive load while using our system. And the results are presented on our poster, which is poster number 67. Yeah, we even brought our rover with us, so come by, say hi, and you can check out our telerobotic simulation system. Thank you.
Hello everyone, my name is Brennan, and I'm a second-year grad student at Georgia Tech. I'm in Dr. Tom Orlando's research group, and I'm also part of the Reveals survey node. My research has focused on micrometeorite impacts on spacesuits and on the lunar surface, and so I'm in the process of developing a laser-induced microparticle accelerator, and this is just to simulate the micrometeorite impacts. And so please come by my poster, number 32, and I hope to get a chance to meet all of you and explain my research just a little bit more detail. So thank you for listening.
We get another big round of applause for all of our presenters, please. And nothing against Greg Schmidt's opening talk, but that's always my favorite session of the forum.